Hello everyone. Look at this one. What is this? This is a bicycle, right? When we look at the wheels of this moving cycle, the wheel moves on the ground along a line, which we can call it as a tangent to the wheel. The wheel is in the shape of a circle. And what about this tangent? What is meant by the tangent? Let us learn about this tangent and the circle in this module. Look at these things. What are they? This is the bangle and a few coins are there and one carom board striker is there. All of them are in which shape? They are all in circle in shape. We have already studied about the circles and the various terms related to circles in the previous class, that is the 9th class. Let us take a flat surface which is called as plane, and on it anywhere you take a point and fix it, and from this point if you collect with a fixed distance, then you are going to get, see, in this manner you are going to get a circle shape, you are going to get it. So by joining these all points, different points which are at a fixed distance from a fixed point, we can call it as a circle. This fixed point we can call it as a center of a circle. And take a point anywhere on a circle and join it, then you are going to get a radius. Let us take 2 points anywhere in a circle, join them, we are going to get a line segment which is said to be the chord of a circle. Like that, so many chords we can draw in a circle. In it, one among them is, which is nothing but, which passes through the center of the circle is nothing but a chord, and which is the longest one. We are going to call it as diameter. It is, see, this is one radius, this is the radius, 2 times the radius gives the diameter. Consider a circle and a line. There are 3 cases regarding the position of the line with respect to the circle as shown. It can be in this manner, they both can be non-intersecting. It may be in this manner, the line may be in this manner, which is passing through the circle. It may be in this condition also, which may touch the circle. In these 3 cases, we can say that here this AB is a non-intersecting line to the circle, and here coming to the second position we can call it as a secant, this line as a secant, and coming to where it touches in a third case we can name it as this line as tangent. In this case a circle is there and a line AB is there. This is the first position, and coming to the second position is a line AB is passing through the circle, and in third position line AB is touching the circle. So in the first position AB is a non-intersecting line, and in second position AB is cutting the circle at 2 points, name them as C and D. Now this AB is said to be the secant, which is making into the circle into sections. Because of that reason we can call it as a secant. And coming to the third case, so AB is just simply touches the circle. We are going to name this AB as tangent. It means tangent comes from the Latin word which is the tangier, which means touch. So in it, this line is exactly touching at one point name it as P, and this P is said to be the point of contact. This is a common point to the circle and the line, and this AB is said to be the tangent. So tangent is nothing but a line meeting a circle only in one point is called a tangent to a circle, and a line which intersects a circle in two distinct points is called a secant of a circle. So here AB is said to be the secant. Here AB is, this is the secant. And in this case AB is, this is said to be, AB is tangent, and P is said to be the point of contact. It is nothing but a point at which the line touches the circle is called the point of contact. It is only exactly one point which is common to the tangent and the circle. Look at this bullock cart. You must have seen this several times in villages. Have you ever noticed about the position of this road and the wheels of the bullock cart? If yes, you might have seen that the road is a straight path and wheels are always in contact with the track. Hence we say that the road is a tangent to the wheels of the bullock cart, and by performing this activity we can understand the existence of a tangent to a circle at a point. Just now only we have discussed that if a line touches the circle, it is said to be the tangent, and this point of contact, this is which is the common point to the circle and line, is said to be the point of contact. So at this point, suppose if this line is rotated, see this is the point of contact, right? So I am taking in this manner, so same in this manner. If I rotate in different position this line, see the condition here in different position. So what we are going to get it, the remaining, these all things we are going to get like a secant positions we are getting. These all positions secant positions. See the condition. We are going to get secant positions. This is a line which is cutting the circle into two sections. Secant. Only at one position only it is going to become a tangent. At this position only it is going to become a tangent. It means at this point of contact, so only one and only one tangent we are going to get it at the point of contact. So look at this. Here AB is the tangent to the circle and P is the point of contact. If AB is rotated in this manner, in this in a clockwise or else anti-clockwise direction, at the different points you can see this one different positions. This PR1, it is like a AB position, one position of it. It is cutting the circle at R1, and one more position, this is the position, it is cutting the circle at R2, and one more position, this is also one more position, it is cutting the circle at R3. In all these positions, PR1 and PR2, PR3, these are all called as secants. But here coming to this AB, this is only one tangent which is touching the circle at exactly at one point, right? So we can say that thus there is only one tangent at a point of a circle. Let us take a circle and a tangent, and suppose if it is in this position we can call it as a secant, right? So this AB line AB secant. So here if I move here upward direction, see the condition, it is going to increase its side, its length, and afterwards it is going to decrease, gradually it decreases, and it comes to one end which is nothing but a common point, it becomes like a tangent. Even from this position, if you come down, here also you can check that it gradually decreases its length here. This is said to be the length of the secant. This line is said to be the secant and this portion is said to be the length of the secant. This length of the secant gradually it decreases and afterwards it comes to one position that is nothing but the limiting position of the secant, which is nothing but a tangent. It comes in this manner, like in this manner only it comes. Whenever you take a circle and when you draw the secant in different positions, see from here to here, I am taking this AB. It comes, if it comes down, gradually it decreases and it comes to this position, length of the secant, it gradually decreases. It comes to one position, one end. This is nothing but a limiting position of this secants. This is nothing but the tangent here. And even if it goes up also here, upward direction, here also it is gradually decreasing and it is coming to one position. It is nothing but a point of contact and this secant is becoming a tangent. And here you can say that at most here, these are all like a parallel lines. See, at most how many tangents can be drawn? Here one tangent is there, here one more can be there. To a circle, we can draw at most 2 tangents in parallel. Look at this bicycle and the wheel is in a circle position and regarding this spokes are there of the wheel. When they are in contact with the road, at one of the position, thus this spoke is exactly perpendicular to the road. The straight part is said to be the tangent and wherever it is contacting, this contacting point to the wheel and this path is said to the point of contact and this straight line is like a tangent type. Now here it is, you can observe that when it is moving at one position exactly it is coming like a perpendicular in position. That is nothing but the point of contact. Let us learn about this one of the important property of the tangent, that by doing the following activity. Now draw a circle and a tangent and you join this center and to the point of contact. Name it as here, this is the center as a O and here this tangent as AB and this point of contact as P, and take a point on this AB which is outside the circle, name it as Q. Now here cut this OQ and seize it according to the OP. When you seize this one, see exactly fold. So you are going to get, it is coinciding with this line, straight line, this secant. So from this what we can say here, if you look at this one, here also one more, the triangle is going to come, here also one triangle is going to come. When you take this one congruency properties, we can show that this triangle is congruent to this one and by the CPCT you can say that this angle is equal to this side angle and if the two angles are equal and the sum of the two angles is 180 means each is equal to 90 degrees. So let us show this one by giving the proof geometrically. Now we are going to show that one of the important property, that is nothing but the tangent at any point of a circle is perpendicular to the radius through the point of contact, that is tangent is always drawn at the point of contact is always perpendicular to the radius. So look at this, here we have a circle with the center O and AB is a tangent and P is a point of contact in it. Now join this OP and you take a point Q on AB and when you join this OQ, it intersects the circle at OR. Now we are going to show that this OP is perpendicular to PB, we are going to show that. So when you look at this figure, so we can see that here OR is equal to what we can write it here. In that one figure, we can say that in the figure, this OR is equal to OP is equal to, it is nothing but radius. I am taking it as a radius. And when you take this OQ, you can write that OQ as OR plus RQ. In OR place, I am going to write this as a radius na. So R plus small r plus RQ. It means it is greater than R plus something. So clearly I can write it as OQ is greater than R. So R, it is nothing but OP, also you can write it, because OR is equal to OP is equal to R, right? So in this place I am writing now this OQ is greater than OP. So from the figure itself I can say that here this is nothing but OP is, P is a point on a circle and Q is outside the circle. It is very clear that this is OQ is greater than the radius. And we know very well in the 9th class itself we have learnt that to any straight line from a point not on it, if you draw the lines to this straight line, then you are going to get in this manner. So in it, among these all things, this is the perpendicular one, and which is the shortest distance from this point P to this AB line. When you see this one here, name it as Q and you take it as R and S. Here you see PQS, PQR is a right angle triangle. In it, PR is nothing but a hypotenuse. Obviously, the hypotenuse is the greater than the remaining two sides of a right triangle. So I can say that this PR is greater than PQ. Coming to PQS, if you take it, then it is nothing but it is also a right angle triangle, and I can say that PS is greater than this PQ. Coming to, if I take this as a T, in PQT also PT is greater than PQ. So among all these things, PR, PS, PT and PQ, PQ is the shortest distance. Same this side also, in that manner only you can show that. So clearly we can say that the perpendicular drawn from the exterior point to any line segment is the shortest distance. This concept I am using here, that here I can say that here as OP is less than the OQ, so I can say that here implies OP is the shortest distance. To AB. It means I can say that implies OP is perpendicular to AB, I can say. OP is perpendicular to PB, or else OP is perpendicular to AB. OP is nothing but what it is? R. And AB is nothing but what it is? Tangent. So this is what we have to show. The radius is perpendicular to the tangent. The radius which is drawn at the point of contact is perpendicular to the tangent drawn at that point of contact. This is what the theorem 10.1, which is one of the important properties of the tangent.